Hey out there in the FIRST community, it's Craig Maynard and Max Call back again, first senior mentors for FRC West, First West, and we got a very interesting discussion tonight. We're going to be talking about FRC wiring. We're going to be talking about all the pros and cons and the intricacies in getting the wiring done in such a fashion that no matter how aggressive your robot is, those wires don't pop loose, the connectors don't pop off, and you get yourself a nice solid connection. So I'd like to introduce you to Warren right now. He's from Kelowna. He's got a huge amount of experience in aircraft grade wiring. So I'm going to turn you over to Warren right now, and he's going to talk to you about all the important details. Hey, Warren.
Hello, FRC. Go ahead. Hi, FRC community. Thanks, Craig, for the invite to come and talk to everybody. Yeah, my background in aviation really cements the importance of wiring. Of course, there's a lot of standards in aviation to make sure that your wiring is solid, to make sure that the connections are good, and this provides a real good foundation for the business I started 5 or 6 years ago, and that's building 3D printers. So as you know, 3D printers are robots, and wiring is just as important in those as in aircraft. So I've got a lot of different techniques and some tips and tricks on some of the wiring basics, and I hope that you can find some of this valuable. Do jump in and ask any questions, and maybe I can clarify some of the points I'm going to bring out. So if it's okay, Craig, I'll just start my slideshow.
That sounds good to me.
All right. Is that, you can see that there?
It's perfect.
Okay. So I just want to bring out my slideshow here is let's talk wiring. So 3 points of focus that I want to talk about, as well as some tips and tricks for each of these different points. Number one is wiring basics, and then from there we can talk a bit about the standards for wire gauge when it comes to the amount of power you can put through different wire gauges to not exceed any standards, and then some soldering tips and how to do soldering well, and some of the art of soldering. So there we go. All right. So some of the wiring basics. When you're doing any kind of wire stripping, it's always important not to damage any of the wires, because generally you have multiple strands. In aviation, we can only damage 2 or 3 strands depending on the size of or the gauge of the wire. So it's always important not to damage that, and there's definitely some tools out there that will help you not damage any of those wires, as well as wire crimping tools. Now, there's lots of tools out there depending on what kind of crimping you're doing, and it's those tools that will help you. You know, using a high quality tool is definitely worth its money, because you won't have as many broken crimps or difficulties using the tools if it's the right tool for the job. And then standardizing some of your wiring practices when it comes to how you do wiring. So once you establish some of the basics, it becomes easier to then establish kind of a standard as to how you build your plugs and everything. So I'm just going to switch back to my camera here, and then I will I'll then be able to show you some of the tools I use. Get this camera adjuster here. So here's a typical crimp tool. So we would use this for crimping some of the smaller crimps. So when you're using the smaller ferrules like this, I don't know if you can see that, they get pretty small. And one of the issues with that I find and have trouble with myself with any kind of crimping of these is once you get this into your tool, it can actually be a little bit tricky to get your wires into there. One of the keys that that you got to remember when you're putting your wire into here is get as straight as you can so that none of those wires pop out. And then once you do your crimp, it's always important that after you've crimped, you always test your how strong it is. So if you pull on it just with a little bit of tension and it pops out, then that's not a good crimp, and you can just toss that and do it again. It's so important that your crimp is solid. If it comes out, it never was a good connection, and you just won't get good connections out of that. Some of the plugs that I use all the time, and these are probably familiar to you, are some of these type of these little plugs here. I don't know if you can see that. There we go. So it's these tiny, the tiny plugs that are used for plugging into. Let's see, I got a sample here. When you plug into this type of pins, so these are like 2.4 millimeters apart. And all right, so that's with the wire crimping. Of course, like I said, there's different types of tools you can use. This one here is for the larger type of. These are probably ones you recognize a little more. So these would be your terminal ends. All right, and then this one here, you can see actually on this tool, you can actually see that they are color coded. You've got the yellow here, blue, and red. So these are all pretty standard. So the blue, it would go into the blue of this one. This tool as well is the jaws of this one are actually removable. So you can put in different types of jaws depending on what types of crimping you're doing. This tool is for the larger crimps like this one. Okay. Now when it comes to wire stripping, there is a way to use cutters like this. We call these DAGs, or diagonal cutters. And you can use that for pulling off insulation. Very tricky to use these without damaging your wires. You're always better off to use a actual stripper. Just grab what my strippers look like. So I have a few different types of strippers I use depending on that wire thickness that you have. So this is kind of an all-around wire stripper, probably the most common you would see in a hardware store. This one I don't use that much. This one is not used as much as, say, these automatic strippers here. So this one here, what it does is it will grab the wire and it will strip it at the same time. So if I grab a wire for you here to show you. So the nice thing about this tool is it will grip the wire, and then in one action it will strip it. Okay. And it provides just the right tension to strip it without damaging the wire. And this works for multiple different gauges, and you can also set the depth of your wire stripping as well with this part here. This one is relatively inexpensive, works well. It also does have a bit of a crimping tools here, but the results you'll get from this are not near as good as you'll get from that purpose-built wire crimpers like these. So well worth the money to get something that works really well. You'll just get better results, less hassle. And then there's this type of stripper here. These ones are for higher gauge or lower gauge wires, for the thicker ones. So it has multiple different teeth here for getting different size wires. Again, it strips in one action. It grips the wire, and then it cuts it and pulls it apart and strips off the insulation. You may have seen some like this. Again, these are great strippers for not damaging the wires. Okay, I'm just going to go back to the presentation here. And just show you. So for the wire gauge, it's always important that you get the right wire gauge depending on the amount of power you got going through your wires. You just do a quick search on Google and you'll find many different different calculators you can use where you put the amount of power, voltage, and it'll then tell you what your wire gauge is. So here's some standards, kind of quick reference to some of that. So you can see here, down at 26 gauge, which is about the size of that wire that I just stripped, that do the maximum amperage you would do there is about 0.3 amps, right? So this is probably about what you would need for a stepper motor. Stepper motors are right around that. Generally, your drivers for stepper motors don't put out more amperage than that. And then, of course, this is for 12 volts. Okay. So, but just make sure you double check that, and always check your calculations to make sure you don't exceed that. You'll melt wires and cause yourself some issues, definitely, and you don't want that happening on a competition. Let's just go. Soldering. So soldering is something we're all afraid of. It's a bit, it can be a daunting task. However, with some good tools and preparation, it's definitely not so bad. The key is it really does take 3 hands to solder, sometimes 4. So it's good to have that third hand. And if you're not familiar with what a third hand is, it's basically alligator clips. I'll just go back to show you what I have on that. So this here is what we call third hand. So the third hand is really this clip here. So this is where you would take a wire and you can clip it in there. And when you're doing your soldering, you take your soldering iron and you're soldering. It's a lot easier to hold the other wire when you're coming in to do your soldering. So the third hand is extremely useful for that. And this particular one here has a place for me to put my paste, the solder paste, and I just put my spool of solder right on top of here. And when you're using it, you just have it sitting there, and then it's ready for you to come in with your iron to get the solder. Now, I don't want to get into showing you just how to solder. There are tons of videos online that you can look at to show you the step-by-step how to do soldering. But I think the most important thing is if you have a good soldering set, a nice setup like this where you can just, you rest your hands on the desk whenever you're soldering, keeps everything steady. The more steady you are, the less likely you are to have cold solder joints. Cold solder joints are not good, and what will happen with a cold solder joint is your connection will break over time. You've got to be careful about that. And when you see the videos, they will talk about cold solder joints and what they look like. So if you want to see what a nice setup is for soldering iron, I like this one. It's relatively inexpensive. This set here, this one here is about, you can order this online for about $90. And what it is it's the hot air gun. So this one is the gun for, I use it for heat shrink. It's not really meant for that, but it works for that. And then the soldering iron itself, which is here. I guess that's a bit hard to see. So, yeah, if you look at that. So the way I've got this is This part here is normally just on the side, but because I move my soldering iron all the time around, I've just secured it to the top of my solder station. And then you have to have your pad here to clean off dirty solder. And you also have to have, this one's really important that a lot of people select to use. And what it is a brass Brillo pad. And you do need that to really clean off your soldering iron. And then a place to place that. This one here is nice. It's got temperature settings here. So if I turn that on, you can see that was the temperature set at, and then it'll increase from there. And then you can control it. So a set like this is less than $100, and it's well worth it if you're doing a large amount of soldering. It works really well. So that's a little bit about that soldering. Again, check out some YouTube videos. There's tons of info out there for showing you how to do soldering. Let's see. Heat shrink. Heat shrink is one of those things where when you forget it, people tend to use electrical tape. Take the time, use heat shrink, and your connections will be just that much better. It kind of forces you to make sure you have a nice, clean solder joint without a big globby mess, because you do have to keep it small enough for the heat shrink. You'll see in some of those videos when they show you how to solder, it's really important that you don't put too much solder. You only need enough for it to weld the wires together. So. Let's see, I will go back to this presentation now. All right, so just moving on here, whoops. Yeah, I think that was the three things I wanted to hit on there, is the wiring gauge, some standards for that, the soldering, and some of the basics around stripping and crimping crimping. There's lots of tools out there. There's lots of different ways to do it. The key is really just to take your time with it. The better your solder connections are, your crimps are, and the cleaner your wiring is, the less troubleshooting you're going to have to do. When you're doing all of your wiring as well, the other thing I want to talk about is tie wrapping and securing of wiring. So very important that okay. Yes. So very important that tie wraps, your best friend. So go ahead and use a lot of tie wraps to secure your wires. You don't want them floating around where they're going to catch on anything and rip out. That'll cause you all sorts of problems. So, Craig, I think that's about it that I wanted to kind of talk about this. If you have any questions for me, shoot.
That's fantastic. Can you hear me okay, Warren?
Yeah.
All right. No, as I said, wiring is a huge problem. In the robot competition itself, when the robots are jostling around, one of the principal causes of lockups on the systems are the wiring. You know, connectors pop loose. A small little bit of wire breaks free from the insulation, and a strand falls into the control system, locks up the processor. So tight wiring, it's the nervous system of the robot. And if you don't have a good nervous system, the robot's going to be unstable and unpredictable, and that's the last thing you want.
Yeah, I know that hooking up our 3D printers and plugging all of that in, there's always some troubleshooting involved, and you know, and from my years in aviation, 90% of problems come from a loose wire, corroded wire that's not connected, and yeah, it just causes nothing but problems. And once you get some clean wiring in there, you clean it up, and generally things work the way you hope they do, or they're supposed to.
Yeah, fantastic. Warren, thank you very much. Now, tell me a little bit about your company. What do you do up in Kelowna?
I just moved the company here in June, so we just relocated to Kelowna, and we've been building 3D printers for 6 years now, and so I'm primarily, we're working with schools to bring 3D printing into schools, and the printers we build are 30% of the parts that we put into our printers are actually 3D printed. So a lot of simple parts like this, a little tool holder is 3D printed, and we mount that into the printer. A lot of, for instance, even something like this is, you can see these parts here. This is where you can see some wiring in here.
Oh my gosh, yeah.
This plate here is actually 3D printed and then mounted to the rest of the components. So just like the robots you guys are building, using 3D printing within your robot, you can really clean things up.
Absolutely.
These, for instance, are little, this is for anchoring of tie wraps. So this
That's a
3D
brilliant
printed
idea.
part here is for anchoring tie wraps.
So you can attach
So you
that
take
on.
that and you hot glue that. What's that?
So you can anchor it on. You can hold it on the structure of the robot.
Yeah, that's our anchors. We stick those wherever we need them for anchoring down the wires. That's really, if you don't have a way to wrap your wires around something or tie them in, just throw some anchors on there and then tie wrap it in place. It's one of the standards in aviation is you can't go, I believe it's around 6 inches or longer without some sort of security to the wiring bundles. And it depends on the size of the wiring bundles as well.
That's the same in industrial automation too. Factory automation,
right.
the vibrations of the equipment, they'll just shake those things loose. Yeah. I saw one group that had they 3D printed a little wire clip. It looked like a comb, except it was a whole bunch of semicircular little guides on a plate, and the wires snapped into it, just like my fingers. And they had a bunch of these things that kept those wires like a set of guitar strings on a guitar, parallel and nice. And it was so easy to troubleshoot. I see so many kids that'll, they're anxious to get the work done, and the teams scrimp on the wiring quality, and the wires are all bundled together, and they got big current wires wrapped up with high sensitivity, stepper motor wires. I see, and it's very difficult to see where anything's going, what's going where. So you can save yourself a lot of troubleshooting time if you guide your wires nicely, right?
Yeah, absolutely. That's, for me, I showed you guys this thing here.
Yeah.
This little device here is really for plugging in the stepper motors, and they all plug into there. I don't know how well you can see that.
Yeah.
But you can see that you can plug anything in here, and then what you plug into here is a ribbon connector.
Right.
And it's that ribbon connector that you can then use to, if you use something like that, you'll always be able to have a standard to that in terms of where it goes, because the ribbon connector is, of course, has a tab to it and can only go one way.
Yeah.
So you have a way to guarantee the way things go. And for troubleshooting, having connection points is great.
Yeah.
Because if you have to desolder things every time you want to troubleshoot something, it becomes a very long process to troubleshoot. So you always want to use plugs in certain places. So you can pull the plug, put another component in there, make sure whether it's the component or the some part of the wiring. Having breakpoints makes that troubleshooting process a lot easier.
Yeah, or places to get a voltmeter into to make some important voltage measurements without having to pull wires apart.
Yes, absolutely.
That's a great idea. Well, Warren, thank you very, very much for coming to see us tonight and sharing your experience in professional wiring, aviation grade wiring. You were a graduate from St. Polytech a few years back, weren't you?
Yes, I was. I graduated in 19...
back then, eh?
I think it was.
Yeah, that's a great program. Aeromechanical technologist, I think. Yeah.
Yeah, I worked 25 years fixing helicopters. I did
Wow.
10 years around BC, Alberta, other parts of Canada, and then the last 15 years of my career, I was traveling internationally for supporting offshore oil exploration.
Oh yeah.
So I've been in Africa, Thailand,
Ah,
Georgia, Kazakhstan, many
fantastic.
places.
Wow, it's very exciting. You can go a lot of places when you know your stuff.
Yeah, it was a lot of fun for sure.
All right. Okay, thanks, Warren. Okay,
Well,
well,
thanks
I've
for
got
having me, Craig. I really appreciate it.
it was a lot of fun. I've got a little presentation I wanted to give on the specifics of the control systems for FRC Robotics. If you could stick around and help me out a little bit with it, I'd appreciate that.
Sure, I'd love to. Yeah.
Okay, let's see if I can get the presentation going. And there we go. All right, is that showing up there?
Oh, I'm Craig. I am not seeing.
Oh, I guess no. I don't think you would. Hold on, I'll have to. Yeah, it's not going to show up on Google Chat unless I do a share screen with you. And I'm just going to put you onto this. How about that? Can you see that?
Yeah.
Do you see that? There's the presentation up again.
Ah, there we go.
All
Yeah.
right. So this is a little bit about the FRC electrical control systems. I wanted to, as long as I had everyone's attention. FRC control system, you know, it's been evolving for a long time. I mean, FRC's been around now for 15, 20, 25 years. And it started off very, very simple. The very first control system I used way back in the 90s was this system here from Innovation First. And it was a pretty good system, a little clunky, and it used those. You can see the radios up there on the system that we used. It was a nice system, and from there we evolved into what's called a C-RIO or a compact RIO. And the C-RIO is a system from National Instruments, and that was a system that was actually a PLC that they repurposed for FRC Robotics. And it was a great system too. National Instruments makes some good things. It did have a lot of loose wires in this particular one. I remember there were ribbon cables, there were daughter boards, there were outriders, and all kinds of points of failure in it. And they had some grounding issues too. If you connected the chassis of the C-RIO to a metal frame on your robot, it actually could blow out the control system. So other than that, it was a pretty nice little system. But our most modern system is the Robo RIO, an improved version of National Instruments, much more powerful processor, and all the ancillary parts are also nicely supported in the system. You can see we've got the power distribution boards, we've got the pneumatic controllers. Everything's all been reworked for the last few years, and they've been a godsend. They've just been a very nice system. Easy to troubleshoot, much more robust. I think it's by far the best system they've had yet. And this is what comes in our kit of parts. I mean, the RIOs and the power distribution board and a lot of the peripheral devices, there's thousands of dollars worth of technology that FRC has given you in your kit of parts. So here's a little video, and I'll put this video, this whole presentation up on the web, so you guys can enjoy it later. But it was the actual launching of the Robo RIO when it first came out a few years back. But I'm not gonna go through that right now. But this is the Robo RIO, and for you folks who haven't seen it before, it's a complete system. Can you see everything there, Warren?
Yeah.
Yep. It's got a whole stream of digital I/Os here for turning devices on and off. Those are called discrete signals. It's got a little plug in here for the robot signal light, which is an orange light, yellow light that sits on the robot, and then it indicates what the robot status is, whether it's in run mode or autonomous mode, or whether it's offline. So that goes to your robot signal light. You've got some high current outputs right here. These are relay controls. Can you see my mouse on there? I'm not sure it's actually showing up. I'm going to have to Let me put an arrow there. Is it showing up? I don't even think it's. I don't think it's showing up on the screen. Pointer options. Let me go to. I'm going to go to a pen. Let's see if that works. Okay, you can't see the pointer, but you can see the pen. All right, there's a digital I/O, and I'm going to make the pen nice and red because I'm an instructor. I like red pens. These are analog inputs. These allow you to bring in various analog voltages between 0 and 5 volts to the system. This area over here is your pulse width modulation inputs. Now, PWM is a signal that uses the width of a square wave to be able to control the magnitude of things. You can, for instance, you can make a servo motor turn a certain degree by the PWM output. You can control the big motor controls, the talons and such, to control the large motors at various speeds. So this is our pulse width modulation controls. We got some status LEDs down here in the corner. We have a serial peripheral interface connection right here for getting data streamed in. We have our Ethernet connection. We have a couple of USB hosts and the USB devices on here, so we can be both ends of the USB system. A beautiful little power connection here that screws on nice and tight. Controller area network bus for communicating with our peripherals right there. This is another kind of a bus system called I2C, which is another very useful industrial standard bus system. We have a serial port right here, RS-232, which can be used for communicating with peripherals as well. And the nice thing about this is it's all in a nice little plastic case, low profile. You've got these little, right over here on the sides, you've got these little holes that can be used for zip tying your control board down to a surface. You can also take there's some screws on the bottom of it too. You can actually screw it right onto a control panel. So a really nice control system. And if you're good in electronics, and I think that you probably are, Warren, there's actually a custom electronics port where you can add on your own daughter boards right here to do all kind of fancy stuff. Yeah. So if what it gives you isn't enough, you can expand on it from there. Very fast processors on there. It's got field programmable gate arrays, complex programmable logic devices in there, and a very powerful processor system. Now, aside from that, this is that power distribution panel you guys are going to have in your kit of parts as well, and it's got the ability to take in all the main power in from your batteries and come into this port right here. That's our DC in, 12 volts, high current. So we're talking, 30 amps, 40 amps, maybe more of current flowing in there. So as you can imagine, we'd need a pretty low gauge wire coming in here. We got status LEDs. This is the CAN bus right here, and so we're going to talk about that in a few minutes. But this CAN bus communicates with your Robo RIO, and all of the current that's flowing through each one of these branches here is relayed back to the Robo RIO to tell it just how it's doing, how much, which motors are using a lot of current, which motors aren't, if there's a lot of noise on the system. Fantastic information comes back to the Robo RIO from the CAN bus. These are your 12 volt outputs right here. These are the high current outputs you can see here, and then there's some lower current outputs right there. They're also 12 volts. You can have and you have power, special power that goes straight out, so there's an actual regulated voltage coming out here that goes to your Robo RIO to power it up. You've got and this is the fuse for the Robo RIO. So it's the power distribution panel, nice and neat. You get the wires put into these WAGO connectors here, and they're just really solid. Pretty nice, eh, Warren?
Craig, those breaker points, are that just using auto fuses?
Yes, they're putting in they're resettable fuses. Yep. So you can actually load in. They're not here right now, but you can just slip in some breakers. We'll look at that in a couple seconds, depending on what you hook up to the outputs. The lower current ones go down here, and the big high current breakers for your main drive motors and such, they go in over there. And the power distribution wiring, this is a great little video. Again, I'm not going to show it because we're I don't want to keep people for too long, but if you download this PowerPoint presentation, it'll have a link right to this video, and you can have a look at one of the groups talking about the power distribution board wiring. This little fella right here is another module that you're going to be getting in your kit of parts. It's called the Pneumatics Control Module. Now this module here has 12 or 24 volt solenoids. So you can see right here you have outputs for 12 or 24 volt solenoids to turn things on and off. There's 8 channels, 0 through 7. You've got a little status light right here in the middle. You've got a connection right here that goes right to your compressor pump. So your 12 volts to your compressor pump comes out of there. I've always been surprised at how tiny those wires are going in there, because that compressor pump sucks out 5 or 10 amps of current. But that's what that's supposed to be for. And your pressure sensitive pressure switch that detects the pressure of your pneumatic system, it goes in over here. And so when your pressure gets to a maximum pressure, you want to have these contacts close and the compressor is automatically turned off. So the pneumatics control module takes care of all the pneumatics plus a whole bunch of solenoids, and it's got an input right here, a 12 volt input that has its own special connection to the power distribution board. Beautiful little system. And it's got a CAN bus interface, a controller area network bus interface that goes back to the Robo RIO, and it can use this to communicate with it. Gives the Robo RIO information, and the Robo RIO can tell it when to turn the pump on, when to turn it off, and when to turn the solenoids on, all that stuff in one beautiful little package. So that's one of the modules that comes in your kit. This is an example of one of those little WAGO connectors that we were talking about earlier on. And here you can see a beautifully stripped wire. Notice there's not much conductor showing right there. And how when it goes inside the WAGO connector, you can see how it crimps down on that wire and holds it nice and tight. So Warren, in your opinion, when you're using connectors like this, should you tin this wire going into it? Should you tin the wire going in, or should you leave it stranded?
Well, I tend to tin wires that I'm going to screw into a screw down terminal. I'm not that familiar with a connector like this, but I would suspect that here you would want to leave it untinned.
Yeah, that's kind of what I've heard too, and that's good advice. If you're going to screw it down tight, you probably want to tin it. If you squash it with the screw, you'll actually break wires, right? But these guys here...
Yeah, and when you screw down a terminal onto the untinned wires, what can happen is through some heating and cooling cycles, it'll actually loosen enough that it'll pop right out.
Oh, that makes sense. Yeah. Oh, okay. Okay, this is another module you guys are going to have in your kit of parts. This is the voltage regulator. What the voltage regulator does is takes 12 volts in from your power distribution board, and sometimes that voltage is a little noisy and unconditioned, not really super clean, and it takes it and it conditions it. It gives you some beautiful, much smoother 12 volt outputs. There's a 2 amp output, and there's a few half an amp outputs right here. And it gives you a couple 5 volts output. There's a 500 milliamp output and a 2 amp output. These are useful for your radio, your wireless data set. And there's some indicator lights there. So there's no CAN bus on this. It doesn't really need to communicate too much. It's just a way of smoothing and preparing voltages for different circuits in your robot control system. Now, when you guys want to start hooking your robots up to motors and high current devices, you got a huge choice. Here's 5 of them right here. Here's the Jaguar, which is a venerable old thing. It's been around for a long time. Got the cooling fan in it. They just didn't build them. Well, in those days, they didn't have the technology to make them run cool enough. This is the Victor, another analog motor controller, again capable of driving 10, 20, 30, 40 amps of current. The Talon, you can see them getting smaller. Then the Victor SP getting smaller still. And here's the Talon SRX. So this kind of shows you from left to right just how beautiful the motor controllers have been getting over the years. And these Talons they're capable of communicating with communicating with with CAN bus, and some of these older ones like the Jaguars and the Victors, they used to use the pulse width modulation. I think the Talon did too. Pulse width modulation into these little spots. Was it? Maybe that's it right there, to control them. But the new ones, all controller area network bus. Beautiful motor controls. This is another module you can have in your robot system here. It's called the spike. Now what the spike is, this is simply a relay. It takes a large amount of current from your battery, lots and lots of current, to drive a huge solenoid. And that solenoid could then operate, I don't know, it could pull a pin down off one of your shooters to release a spring tensioned thingamajiggy or whatever. So the spike, basically, it doesn't control analog. It's strictly an on or off situation. And it's controlled through this pulse width modulation input right here. So the spike, very useful if you need to turn something on or off, some high current device. There's that robot stack light we talked about. Not much to know here, except there are actually two lights in here. There is one light that's an A light and one light that's a B light. There's lamp A and lamp B. We like you to connect them both together. So you're turning on both lamps, and then you've got your common neutral return. So, and this goes right into the robot stack light input of your Robo RIO. We mentioned before those two wires. So the robot stack light should be there. This is the power distribution panel. So you can see there's our main batteries coming in. And the batteries are going to be hooked up with the large high gauge wire, low gauge wire here. And you have to make sure you insulate this point very well, because there's actually, we don't want to have any connection between this and negative, because there's no fuse here. So this should be all wrapped up and insulated and protected. A short little wire here goes to your main breaker. This should be all protected as well. You don't want to have any conductor showing here, because if it touches your chassis or gets its way back to ground, sparks are going to fly. However, over here, this is the output of your circuit breaker, your main breaker. Now this is also important that you insulate as well, but at least if this shorts out to ground down here, you'll blow your breaker, right? Now a lot of times in FRC Robotics, they like to use the main breaker also as the main power switch to turn on and off the robot. I've never been one in favor of using a breaker as a power switch. They're just not meant for that kind of stuff. But it works, and it's been doing the job for a long time. So we almost always use this main breaker on your robot as the main power switch too, which is why they've got the little button on here. You can hit this and reset it and then turn it back on again. So keep this thing out in the open on your robot someplace, so you've always got it accessible. Okay. Here's how you hook up some of your old motor controllers. You can see these big motors. These are called SIM motors. The SIM motors, and I think I've got some right here. Oh, is that going to show? It's tied onto my... No, I can't show you the SIM. It's over there. But the SIM motor, high current inputs go into one side. The other high current inputs go over here to your power distribution board. And then this would be the controller area network that goes in to turn them on and off. Okay, there's the Talon motors. Again, you can see the power going in and out to the motors. This is another little video. This is a little bit like the one that you just showed Warren about all the different connectors and things. It's a well done video put together by some students at one of our FRC teams. And again, you can watch that at your leisure. And here's another copy of that wire gauge that you showed. That shows you the length of the wire and how much current it can actually handle. So you can see here, if your wire is 7 feet long and it's 16 gauge, if it's 16 gauge, 7 feet long, don't put more than 18 amps through that wire. And that seems kind of excessive, even at that. But you do notice the shorter the wire, they do give you a little bit more current you can push through the wire. When wires get really long, the resistance goes up. The wires can't conduct as well, so the amount of current you can handle goes down. But
one thing of note there, Craig, is typically the wire length, they are talking about both the positive making it to the load as well as the negative coming back to the frame or to the. So it's actually, if you only need to go, if it's a 6-foot wire, it's actually 12 feet distance.
Oh, okay. All right. So
I don't know if that's on that chart you have there, but just do a quick little research on the distance, because I know that for automotive they do talk about distance from the load back to the. Because
it's got to go from the battery to the load and then back to the battery. So obviously it's doubled in length.
Yeah, or from the load to the frame of the car, which is what they use to transmit back to the battery.
Right. The rules in your First Robotics rule book, when you get it, will specify very carefully what gauge of wire you have to use for every function inside the first control system, which is really good. And your safety inspector at the robot games is going to check those gauges. And if you've got the wrong gauge wire on a certain control arm, you're back to the pits. You're going to have to pull that wire out. So make sure you guys pay attention to your wire gauges. Don't just throw any old wire higgledy-piggledy into your system. It's very important you get it right. So here's some examples of wires that Warren was talking about. You can see 14 gauge. These are stranded wires. These are solid core wires. When would you use stranded over solid core? Warren, what do you think? And there's solid right there.
12? Yeah, that's solid core on the 12, yeah.
Now, household wiring.
Solid core wires are a bit. Yeah, household wiring is usually solid core and a bit tricky to use on electronics. You can't solder as well with it.
Yeah, that's right. I mean, household wiring doesn't usually have a lot of vibration and doesn't move much, so solid core works fine. Stranded is a little bit more expensive, but it's certainly more flexible and capable of being in a more robust situation. So, yeah. Anyways, you can see all the different gauges of wire. It'd be nice if there was a dime or a penny here we could see to get the scale down. Most of my industrial control systems at SAIT, when I'm wiring up, we usually work in this range, 12 to 14 gauge. Okay, and there's crimping wires, another little video you can look at later on. We'll put this on the website. So this is how you would hook up the entire FRC control system. This is 2017, 2018. It's pretty much the same right here. And I'm not going to go into any detail, but this is available a number of places on the web. If you Google 2015 FRC control system layout, you'll see this picture, and it's just a beautiful little description of how everything's all laid out. Right. So I'm going to encourage you to go and explore that yourself. We've got some time for you guys to get ready for your kit of parts to show up, but it's good to have a look at this thing before the actual kickoff happens. Okay, and this is a control system overview. This is a little video here, 6 minutes, that talks about how to wire up one of these guys, and I'll spare you there. This is the controller area network wiring, as you can see here, the CAN bus. Now a CAN bus is daisy chained, so you'll notice there's actually two colors. There's yellow and green, and you actually have a length of twisted pair yellow-green wire in your kit. That's your CAN bus wire, and that twist that's on the CAN bus is specified to match the impedance you have to have for CAN bus. So don't untwist it, right? And don't twist it tighter. Just keep it the way it is. Try not to bend it too tight. And for heaven's sakes, put the yellow wire in the yellow hole and the green wire in the green hole, and make sure that's the same on all peripheral devices. So you can see that the Robo RIO, the CAN bus, goes into the first device, and it can be any device you want. It just happens to be the pneumatic module here. Then it leaves that and it goes into the second device, and finally it's going to end up going to the last device. Now the last device in the system has to have a terminating resistor in it. It has to have, I think it's about 110 ohms, I believe. Warren, do you know? I think it's 110 ohms for CAN bus. So if you don't have any wires coming out to another device, then you have to terminate it. And it's handy that your power distribution module has got that terminating resistor right there. Right, so make sure that it is the last device in the system. So that's your CAN bus. Okay, wire management and cable management, super important. Here's a control system I just drool over. You can see they've got the cable guides right here with covers on the top. They've got everything neatly laid out in the middle here with all the wires going into the cable guides. I don't know what's going on inside. And they've even got some labeling right here to describe what the signal's trying to do. This is a beautiful system. You can buy these runs right here from a company called Panduit. In fact, there's a lot of control system houses you could probably go to that would give you, or panel houses, that would give you scrap ends of this stuff to use in your robot, because they have miles and miles of it. So that's a nice layout, Warren, isn't it?
Yeah, looks good and tidy, that's for sure.
Yeah, I've seen a few robots like that. Haven't seen many, but I can tell you it makes a great impression, and it does make a very nice wiring system.
Looks very professional.
It does, and that's what we're shooting for here. Now, this page right here, I've got a whole bunch of resources for wiring your control panel. WPI Lib is everybody knows this is an amazing site for troubleshooting for learning everything you need to know about the system. So yeah, let me just open it up here for a second, see if it's actually your screen steps live, step-by-step description. I'm just seeing if it's going to come up on my computer here. Let's have a look. Screen steps live. I think somebody must be streaming on my network right now, because oh, there we are. WPI, the Worcester Polytechnic Institute. Okay, and this talks all about wiring the systems, the parts you need to have. It talks about how you lay out the boards. It talks about how you fasten the components down, you attach the batteries, the wire breakers. Man, it's got everything you need to get going on your system. A little video here about the WAGO connectors. So I really don't have to repeat much of what these guys have done, because they've done it so well, all the connectors and things. So that's one good resource for you. This is all about how to wire up the pneumatics. Chief Delphi has also got a huge amount of resources on wiring, and there's some papers right here on the wiring systems and all the details of wiring up a FRC Robotics system. And there's another one from Chief Delphi right here. This is basically one of the blogs. Chief Delphi has this incredible blog, so if you have once you subscribe to this thing and you have any problems with wiring or any questions, you can come to your senior mentors, you can come to Max or I or some experts. But boy, I tell you, you won't get any more information than you can get from resources like Chief Delphi. And here's another link I've given you down here from Instructables. You can look at right here, and this Instructable is all about wiring up an FRC robot, and things you need to have. There's the crimping tools that Warren was talking about, the hot air gun, the cheap garden variety stripper, crimper, screw cutter, right? And how to plan it out, how to mount the components, how to crimp the wires. Isn't that wonderful?
That looks good. Yeah, a lot of detail in there for sure.
Yep, that's right. And there's the ribbon cables you were talking about. And look how they've folded them all up so they don't get all out over the place. Beautifully run. And oh, this is the older system, by the way. That's the C-RIO, so this obviously goes back a bit. But you can still learn a lot about good wiring from old sites like that. Okay, so that's just that'll be available to you guys if you need it. It's always up there and ready for you. All right, Warren, are you still there, Max? Max is still there? I think Max is muted. Max! That's all right. Okay, well, listen, I think we've done our time. The time we got 8 o'clock, right on the nose. So I think that's a good amount of information on wiring. It should be super useful to almost any FRC Robotics team. So I want to thank you again, Warren, for coming on board. It was, oh, there you are, Max. We're just saying good night.
I'm here.
Okay. Good night, Max. Good night, Warren.
Good night, Max. Thanks, Craig, for having me on. Looking forward to checking out the competition in Victoria.
Oh, it's going to be a lot of fun. You've just it's a rabbit hole you can go down a long ways.
It'll be fun.
All right. So next week on the 13th is going to be our introduction to Java. So we're going to look at the basic kinds of environments we can program Java in for both FTC and FRC. We've got an expert from Toronto who's going to be coming online and giving us all kinds of useful information about Java. So we call that one Java Jumble, and we hope we see you guys next week on the First Labs live webcast. Anything to add, Max? Okay, I'm going to let you guys go then. Good night, everybody.
Good night, Craig. Thanks a lot.